Hello, everybody. Today, what we're going to be learning about is the greenhouse effect. The last few days, we've been learning about natural causes for climate change, and specifically, we've been talking about how scientists have measured climate in the past, how we know what ancient climate was like to know that our current climate is changing. Today, we're going to be talking about specifically the mechanisms by which climate change happens, or the ways climate change happens. Um, so we're going to be learning about the greenhouse effect. Follow along in your notes, fill them out as we go through the video. So what we're going to talk about first is the layers of the atmosphere. There are several layers of the atmosphere. The two that we're going to be talking about today is the troposphere. That is the area that has all the breathable air in it, has all of the weather. No weather occurs above this. And then the stratosphere has the ozone layer. The ozone layer is important because it blocks some of those ultraviolet rays that give us sunburn, can cause cancer, skin cancer specifically, and also has a problem with it in that the ozone layer currently has a hole in it. Now, this hole in the ozone layer has nothing to do with the fact that, or very little to do with the fact that we're experiencing climate change. That basically does cause a problem, but it doesn't cause as much of a problem as other things in the atmosphere. The troposphere, the tropopause is between those two layers, and because there's a um, consistent temperatures in each one of these layers, they prevent air movement from moving between these two layers. So these two layers are basically separated from each other, even though it's just air. There's no real thing there. All right, so there are permanent gases in the atmosphere. These do not change from day to day. Oxygen and nitrogen are two of those things. They're the most abundant in our atmosphere. Some other gases, like argon, carbon dioxide, methane, which is CH4, nitrogen oxides, um, ozone, and CFCs, they all change based on the seasons, how matter is being consumed, and how much humans are putting out into the atmosphere. So basically, this is how it happens. This is how greenhouse gases happen, right? Sorry. Greenhouse gases are basically variable gases that absorb heat, long-wave radiation, and radiate some of that heat towards the Earth's surface. So we have infrared coming in from the sun. This is basically just heat. Also, visible light is coming in from the sun, right? It's going to hit the ground right here, um, any surface on the Earth, and the Earth is absorbing that heat. Okay, some of that heat gets re-radiated or put out back into the atmosphere. Now, this is always drives me crazy, the fact that this is shown with clouds. We're just going to say that these clouds are the greenhouse gases. These are clouds do have an effect, but mostly it's greenhouse gases up here, which they do not form like a layer necessarily like this. They're just all around us, okay? These greenhouse gases are absorbing the heat that has been re-radiated. And then we'll re-radiate some of that down back to Earth. Okay? So some of it gets sent back down to Earth and keeps us warm here. Without these greenhouse gases, we would not be able to live on this planet. It would be far too cold here in order to do that. Make sure that you're writing down what I'm writing as you go through your notes. Okay? Some of this escapes back into space. So without this escape either, we would be way too hot. So the greenhouse gases on the planet are absorbing just enough heat and re-radiating it down back to the planet that we are able to stay warm and we're able to have seasons and we can have liquid water on the planet. These right here are the greenhouse gases that we're talking about. Okay? So this is going to be number 2, and this is going to be number 3. Okay? And you can fill in the picture as we go through. All right, so the greenhouse effect, like we said, they stabilize surface temperatures and keep them within a habitable range. Without this, we would be extremely cold. So once the sunlight reaches the surface, what happens to it? There's 2 things that could possibly happen to it. It could be absorbed or reflected. Okay? So we can see that black colors will reflect 0 of that light. It absorbs it all. Somewhere in the middle, this gray absorbs about 50%, and white is 100%. Okay? The very end is 100% affected. So we can see different types of materials that will actually, and how much they actually absorb or reflect. This is called albedo. It measures how reflective a surface is. Okay? This is, sorry, that's 4. And this is 5. Okay? So, here's just some common um, reflectivity, albedo reflection, and how much they reflect versus absorb. Remember, if they're absorbing it, it gets hotter. If they reflect it, it stays cooler. This is for number 6. So grass absorbs about 20 to 30%. Asphalt, reflects 20 to 30%. Asphalt reflects only about 5 to 10%. Fresh snow reflects almost 80 to 95%. The Earth's average albedo is 31%. So you're going to be filling in A, B, C underneath. Okay, so black objects have an albedo of less than 0.1 or less than 10% of the energy is reflected. White objects have greater than 8, more than 80% is reflected. 7A, 7B. Now, we talked about a little bit about volcanic eruptions. Volcanic eruptions release sulfates and particulates, which reflect that infrared back into space. So whenever there's a volcanic eruption, it's going to release that energy back into space, and it's not going to warm up the Earth. Earth gets cooler. Number 8. Okay, ocean water has an albedo of about 0.6. So this is very low. All right, this albedo is very low. Okay, so it's about 6%. Yeah, 6%. All right. So this is the ocean water itself, because it's dark, will absorb the heat. Okay. Sea ice and glaciers have an albedo of about 0.8 all the way up to about 0.8. Okay. So these are reflecting the heat, keeping it cool. Okay, that is it for today. Please answer the rest of the questions on your sheets and complete the rest of the lesson plan. Thanks.